Hello everybody. Just wanted to make a quick video to explain the solutions to the activity that you guys did. In this case, you were given just some basic information about a motion and you were asked to do some things based on a written description. So, first thing you were asked to do is plot a graph of velocity versus time for the motion. You were given the fact that this thing for 4 seconds had a uniform velocity of -2 meters per second. For 3 seconds, the object remained stationary, and 2 seconds, the object moved with a uniform velocity of -4 meters per second. So, for 4 seconds, that's 1, 2, 3, 4 seconds, the thing had a uniform velocity, uniform meaning unchanging, of -2 meters per second. Now, I didn't put every point here because I knew it didn't change. Then, excuse me, for 1, 2, 3 seconds, the object remained stationary, has no velocity. And then for 2 seconds, it had a uniform, unchanging velocity of -4 meters per second. Second thing you were asked to do is, okay, well, plot or make a position and timetable for this. At a time of 0, 1, 2, all the way down to 9 seconds, the entire motion took 9 seconds. You were given the fact that it began at a 20-meter initial position. So going back up here, remember, displacement or change in position on a velocity graph is the area beneath the curve. So if I want to know how far this thing went for the first second, I'm simply going to look at this shaded in area, because from 0 to 1 second, this shaded in area would represent the thing's displacement for that second. And that area would be -2 meters per second times 1 second. This area would be -2 meters. So I know over the first second, the thing went -2 meters, meaning 2 meters to the left. And I could do that for every little 1 second interval, figure out the area beneath the velocity graph. Now I don't need to do that here because this area and this area and this area and this area would all be the same. So for every second, this thing goes -2 meters, -2 meters, -2 meters, -2 meters, all the way to here. There is no area beneath the velocity graph from 4 to 7 seconds. So there is no displacement during that time, no change in position. Then, from 7 to 8 seconds, the displacement would look like this. How big is that? Well, that is -4 meters per second times 1 second. That gives you -4 meters. This area is -4 meters, meaning the thing went 4 meters to the left. And then this area would also be another -4 meters worth of displacement. Now, this whole concept of negative area might be strange to you, but we're taking a negative velocity and multiplying it by a positive time. So it truly is a negative area. Strange, but true. So this should have allowed you to make this position timetable. Now, you may have said, I didn't do all that. I didn't go up to the graph and do all this stuff with areas. Well, you kind of did in a roundabout way. If in your head you just used the initial information that said it moved with -2 meters per second for 4 seconds, you really did do what this graph is showing you in your head, but you used an algebraic relationship. And the one that you used is displacement equals average velocity times change in time, which indeed is the area under this graph. So even if you think you didn't do it, you did it. Like I told you in class, all of these equations actually come from graphs. Next thing you were asked to do, draw a motion map for the object. So down here, the thing began at a position of 20 meters. And I simply used the fact that I had this nice position table, and 18, 16, 14, 12, stayed at 12, stayed at 12, stayed at 12, went back to 8, went back to 4. Keep in mind, this is showing a horizontal motion. This part of the motion map is not implying that the object, went left, climbed a ladder, and then continued to go left. This is really the only way on a motion map to show that an object stays at rest for a certain amount of time. Imagine if I didn't have these dots here and I just kept making it, it would look like an object that went left slowly and then sped up and went left more. It would kind of ignore this whole section where it stopped. Position versus time graph. Just took the information and plotted all of the points. Remember, this is a position graph. What can we get from that? If you recall up here, the area under a velocity graph meant something. Well, the area under a position graph has no physical meaning that I am aware of. However, the slope of the position graph does represent the average velocity over a certain interval. So what's the slope from here to here? That would be rise over run. So let me label there's a run, there's a rise. So the rise is the displacement. How do you get displacement or change in x? You do final minus initial. So position of 12 minus a position of 20 would be my rise. 12 minus 20 is -8. My run is 1, 2, 3, 4 seconds. Here's my run. So this would be my change in position. This would be my change in time. Divide those and you would get the slope, which is -2 meters per second. So the slope of this graph is this graph. This is a constant -2 meters per second slope. So we have a constant -2 meter per second velocity. What's the slope of this segment? 0. Therefore, the velocity is 0. What's the slope of this segment? -4 if you figure it out. What's the velocity for that segment? A constant -4. So this velocity graph is a graph of the slope of this graph. Now the last question you were asked, what would be the similarities or differences in the position time graph if you started at the origin instead of at positive 20 meters? Well, this graph, instead of starting at 20, would be down here. The same motion would have occurred. So this entire graph would look identical except be shifted down. Every single point on here would be 20 meters lower on this graph. So imagine you take this entire thing and just shift it right down. If you started at 10, everything on here would be 10 lower than it is right now. Interestingly, this graph, think about this. You can even pause the video for a moment right now after I ask this question. Would the velocity graph look any different if I began the motion at the origin? Pause it and think about that. Would the velocity graph look different? Well, the answer is no. This motion, this velocity graph only tells you how the object moved. It doesn't tell you where it began. This only tells you how it moved. So this would look identical no matter where the object began. This one, however, would be shifted based on where the object began. You cannot tell. If I simply gave you a velocity graph and said, okay, where did this object begin? It would be impossible for you to tell me that. That would have to be given to you. Now, what you could do, if I said, hey, here's a velocity graph, what's the object's displacement? You might not know specifically where it began, but you can tell me how far it went and what way. You can tell me its displacement. Look at the whole thing. What's the whole area under the curve here? That would be 2, 4, 6, 8. So -8. Another -8. What's the total there? -16. You could tell me, hey, displacement, -16 meters. This thing ended 16 meters to the left of where it began. You could tell me that, but you could not tell me where it began just from this graph. That's a piece of information you would need. Hopefully this helps.